Hi, this is College Algebra. We're going to go over basic equations today. So we're going to learn how to solve linear equations, solve power equations, and solve for one variable when there's multiple. So before we begin solving equations, I want to go over the properties of equality that make up the foundation of equations. So the first property of equality is if we have two mathematical statements, one being A, the other being B, and we know that they are equal. If you are to add a quantity C on both sides of this equation, these two equations that you see right here are equal. They're equivalent to one another. And that has to do with the respect in symmetry, right? So if you are proceeding with adding C on one side of an equation, you have to add it to the other side in order for the equations to be equivalent. So you could not go by doing an addition of C on one side and not the other. These two are not equivalent anymore, right? So that's one of the fundamental properties of equality. And the other is if we have the same equation, A equals B, if you were to multiply by a factor, a quantity C on one side of the equation, you must do it on the other, right? In order for the equality to remain and for these to be equivalent. And just like I previously said with the addition property, it's the same with this multiplication one. CA would not be equal to just B, right? Multiplying on one side wouldn't work if you don't do it on the other. So those are the properties of equality, and now we can look at what a linear equation is, a power equation, and how to solve for variables in terms of others. So a linear equation is, in one variable, is an equation that is equivalent to the form of this: ax plus b equals 0. And in this equation, since we do deal with letters as variables, you have to notice that a and b are constants. So these represent numbers. For example, 2x plus 5 equals 0 follows this linear equation structure, right? So the reason it's called a linear equation, you'll often also hear it as a first degree equation. It's due to this variable x being raised to the power of 1, right? There's no exponential going on here. If we wanted to solve a linear equation, for example, one that looks like 7x minus 4 is equal to 3x plus 8. Where do we start? First of all, we know that this is a linear equation because there is a variable x that's raised to the first power. Everything is in first degree, right? And we have constants all over the place, kind of. So the first step in solving an equation is going to be putting the variables, in this case x, on one side. So we're going to try to move x on one side of the equation and our constants on the other, our constant terms that are not attached to any variable. So what we're going to do first, let's move this constant of minus 4. But how are we going to get rid of it? We're going to add 4, right? By adding 4 to negative 4, we're going to get rid of it. But remember our first property of equality, we're going to have to add 4 on the other side as well. So now we're left with 7x is equal to 3x plus 12. Oh, that was a bad 12. So now we want to move this 3x to this other side with our x and leave our constant terms on the right side. So how do we do that? Just like we did it over here above, we're going to subtract 3x to this positive x, and this is going to cancel. But remember, if we do it on one side, we have to do it on the other. And we're left with 4x is equal to 12. And now our final step is going to be to get rid of this 4, this scalar that is attached to our x, and solve for x by itself. So how do we get rid of something that's multiplying something? We're going to divide by 4. And again, this will cancel, but we have to do it on both sides of the equations. We have to respect the symmetry in order for the equality to still exist. And we're left with, I'm going to write it over on the left here, x is equal to 3. Now, how can we confirm that this is an answer? So we've proposed that x equals 3 is a solution, right? And writing our original equation, we had 7x minus 4 equals 3x plus 8. All we need to do is, if x equals 3 is a solution, it should be able to plug right into this. So we're going to just plug in 3 anywhere we see next. And just multiplying this out and everything, I'll take it step by step. We get 21 minus 4 to 9 is 8. We're left with 17 is equal to 17. And since both sides of the equation are equal, this is a solution, and it works in this linear equation. So now let's take a look at power equations. So we just did linear equations, and that was the first degree equation, right? And power equations are anything of higher order. So it could take the term of x squared, x cubed, and so on and so forth. So in a power equation, when you solve a power equation, it'll result in the simplest form of x to some power n is equal to a constant, right? Because at the end of the day, when you're solving for x, you're gonna want to solve it in terms of a constant, right? So we're gonna end up with this shape when we've solved our power equations. The important thing to know is that there's different properties when you're dealing with radicals and exponents as opposed to just a first order. So what we're going to look at is if n is even. So if n is even, like x squared is equal to a, right? And we'll give a value for a. We'll say 4. How do we get x by itself? We take the square root, and we're left with x by itself, but we must do it on the other side. So we're left with x is equal to 2, right? And plugging that back in, we get 2 squared is equal to 4, and we know that that's valid. But now I ask you, what about negative 2, right? Because negative 2 squared is also equal to 4, right? So this equation had another solution, and because we neglected the negative, we weren't able to find it. So that brings me to say, if n is even, x is equal to the positive and negative nth root of a. And that may seem complicated, but it's exactly what we just did. So if we have x squared is equal to 4, this 2 is our n, and we're going to take the square root, let me write it a little different. We're going to take the square root of both sides, right? The nth root, because 2 is our n, right? So we got rid of our exponent on the left side. We're solving just for our variable x. And now we just have to put this plus and minus. So we get x is equal to plus and minus 2. And that's our solution to this power equation. Now let's look at if n is odd. Oops. So let's have x to the third as an example, and we have 27, right? In order to get x by itself, we're going to take the cube root of both sides. Here, we get x is equal to 3. So we have our solution x equals 3, and if we plug it back in, we know x cubed, 3 cubed, is equal to 27. So we know that's valid. But since n is odd, since we have an odd power, we know that if you multiply a negative number 3 times, like negative 3, you'd end up with a negative output, negative 27. And we know that negative 27 is not equal to 27. So x equals negative 3 is not a solution. And so, you know, when you're dealing with power equations, if you have an even power, since even powers, negative numbers, if they're multiplied an even amount of times, they end up with a positive answer, you know that there's going to be the positive and negative solution for your x. But when you deal with an n that is odd, like 3, like 5, you only get your sole real answer. So now let's look at solving a power equation, and I'll write a power equation here. Okay, so we have x minus 4 squared is equal to 5. And so in order to solve for x here, we first have to get this square out of the way. And like we've shown before, we're going to just take the square root in order to get these out of the way. But just like before, we're going to have to take the square root of both sides. Now, remember, as just mentioned, when you're solving a power equation, if you have an even power, you're going to have to deal with the positive and negative when you take that even root. So we're left with x minus 4 is equal to positive and negative root 5. Then from here, we just have to get rid of this minus 4 and take it to the other side, leave our variables on one side of the equation, and we do that by adding 4. Okay, cancel these, but since we did it on one side, we have to do it on the other. And so we're left with x is equal to 4 plus and minus root 5. And that's our solution. Okay, the last thing we're going to go over in this video before we wrap it up is how to solve for one variable in terms of others. Now this kind of might seem more complicated than it really is. It's similar to everything we've done so far. So take a equation like Newton's law of gravity. F is equal to G So take this equation and say, and you could do this with any variable here, other than f, obviously, because it's already in terms of f. Let's try to solve for this m. So we're solve for m. So how do we do that? We're going to do the exact same things, the exact same steps as we've done before. We want m, this capital M, by itself on one side of the equation, and we want all these other terms on the other side. So let's just separate it from this equation. So here, hopefully this shows that it's its own variable and we want to solve for it. So the first step that we're going to do is multiply by r squared, right? And you see why we do that is because we have a divided by r squared, and in order to get rid of that on this side of the equation, we multiply by r squared. And boom, these two cancel. And remember, as always, we do it on one side of the equation, we do it on the other. So we're left with f r squared equal to, and we have our capital M that we're solving for. So the next thing we do is it's being multiplied by this quantity gm, whatever it is, and all we need to do is, if it's getting multiplied by something, let's just divide it to get rid of it, right? And this completely gets rid of that. We have m by itself. This is exactly what we want, capital M. And as always, if we do it on one side, we do it on the other. Ooh. And so, actually I can fit it. We have running out of space here, equal to our capital M. This variable that we wanted to solve for, we were able to do it with just a couple steps, just by treating these other variables as we've done with constants so far, right? And that is going to be it for this video. I hope you took something away from it, you learned something, and if you have any questions, anything, put them in the comments. Thank you.